Good afternoon.
Okay, block 2 is about the straight line. And if you see unit 4, it is straight line and various forms of the equation of a straight line. So for the equation of a straight line, you have the general form is there. We call even it as a, that is the unsymmetrical form of a line. Okay. So that will be unsymmetrical form of a line will be in the form of combination of two plane equations. Okay. So the combination of two plane equations is like this: ax plus by plus cz plus d equals to 0, and a1x plus b1y plus c1z plus d1 is equals to 0. Okay. These combination of these two plane equations is called as a unsymmetrical form of a straight line. Okay. So if you see in the page number 100, you have the combination of these two equations. So these equations are known as the equation of a line in unsymmetrical form. Okay. So one question you will get in the transformation of an unsymmetrical form to a symmetrical form. So one 5 marks question you will get in the, that is the third question. Third question in section A from this one. So is known as equation of the line in the unsymmetrical form. Unsymmetrical form. Okay. From these two equations, if you convert them into a one form, that is called as a symmetrical form. Okay. So from these two plane equations, that is x minus x1 by L is equals to y minus y1 by M is equals to z minus z1 by L. Okay. This is called as a symmetrical form of the equation of the line. Okay. So transformation of unsymmetrical form to symmetrical form, one question will be there, and this method, whatever the conversion is there, this method is useful for even for solving the problems also. Okay. In some question, plane equation will be given and you will ask to find some of the problems there. For the convenience of the solving the problem, you have to convert the unsymmetrical form into symmetrical form. With the help of that, you can find the solution of the problem. Okay. If in some problems, they'll give 4 plane equations. Okay. From that, if you'll ask to find, show that it is a coplanarity, or to show that the two lines are intersecting, or to find the shortest distance, like this, any problem in that, from the 4 plane equations, from 2 plane equations, you can convert it into one line equation, and another 2 equations, you can convert them into one more line equation in symmetrical form. With the help of these 2 line equations, with the help of some formulas, you can find the problems. Okay. But the conversion of this is very important in this your block 2. Almost, if you know this concept, it is used to solve the problems. Okay. So one problem we'll see in the conversion of unsymmetrical form to symmetrical form. So for conversion of this one, you first thing is you have to put here wherever z is there, z value, you have to take it as 0. And then by solving 1 and 2 equations, you have to find x and y values. And z is also 0 you have. So by solving first equation and second equation, you will get x, y, z values. After that, by taking the perpendicularity of these two equations, by cross multiplication method, we can find L, M and N values. So we got already x, y, z values from here and L, M, N values from the solving with the help of cross multiplication method. If you substitute in this formula, then this unsymmetrical form will be converted into symmetrical form. Okay, that is the one problem you have here. So one problem is find a symmetrical form of equations of the line. Two equations are given. So with the help of that, you have to convert unsymmetrical to symmetrical form. Find symmetrical form of equations of the line x minus 2y plus 3z is equals to 4, 2x minus 3y plus 4z equals to 5. Okay. By combining of these two plane equations, these two are in unsymmetrical form. You have to convert them into symmetrical form.
Excuse me, ma'am.
Yeah, what, ma'am?
Ma'am, there is this in textbook.
I hope so. In any check your progress or exercise, it will be there. See.
Oh.
Okay. The given line equation is, we can write the line equation as, that is x minus 2y plus 3z minus 4 equals to 0. And we can combine this one both like this also. Okay. So I am writing here separate only. And this is 2x minus 3y plus 4z minus 5 equals to 0. Okay. Combining of these two, or else we can write like this also. X minus 2y plus 3z minus 4 is equals to 0 equals to 2x minus 3y plus 4z minus 5. Combining these two plane equations. This is the one line equation. Okay. So the given line is this one. So you can take here separate like this also. One, this is equation 1 and this is equation 2. Okay. Let A comma B comma C be the direction ratios of first to find the x, y, z values, first you find put z equals to 0 in equation 1. To find, either you can find x, y, z values or you can find LMN values. Okay, anything you can find first, this one or that one. Okay, to find point of given line 1, put z equals to 0 in 1. Okay, so if you take z equals to 0 in line 1, okay, better you take like this. This as equation 1. Okay, only one line you are taking. These will be two plane equations. If you combine them, this will be the line equation. Okay, so if you put z equals to 0 in this one and this one, you will get it as x minus 2y. This is 0, so minus 4 equals to 0. And one more is 2x minus 3y. This is 0, so minus 5 equals to 0. Okay, now solving these two equations, here 2x is there, here x is there. So anyone, if you cancel, you will get one more value, no? By solving, you take this as 2 and this as 3. 2, equation 2 into 2 you are multiplying, and 3. We get, so 2x minus 4y, 4 2s are 8 equals to 0. This is 2x minus 3y minus 5 equals to 0. Okay, minus, this is plus, this is plus. So both this will get cancelled. It is minus y equals to minus 8 plus 5. So minus 3. So both minus minus will get cancelled, implies y is equals to 3. So substitute this y in 2. So what you will get, x minus 2 into 3 is 6. 6 minus 4 equals to 0. This is minus 10. So x equals to 10. 6 minus 4. Okay. This is minus 3 you will get, no? I've done here mistake. This is minus y and this is minus 3 equals to 0. So if you take out, that is minus y is equals to 3, implies y is equals to minus 3. So here what you will get, x minus of minus means plus 6 minus 4. So minus 4 means plus 2. X equals to minus 2. Okay, x value is minus 2, y value is minus 3, and z we have taken here, it is 0. Therefore, x equals to minus 2, y is equals to minus 3, z is equals to 0. We got x, y, z values. We need to find the, that is LMN values, or we can tell them it as ABC. Okay, those are the direction ratios of the line. Okay. So first thing is, when you are taking the line equation, we can combine the plane. Two plane equations, when you will combine, that will be the one line equation. So first, put z equals to 0 in 1. And you can separate them as the planes. So this is value is 0, x minus 2y minus 4 equals to 0. 2x minus 3y minus 5 equals to 0. So we have to solve these two equations to get x and y values. So to equate these two, we are multiplying with 2. So we are getting 2x minus 4y minus 8 equals to 0, and this is 2 as it is. 2x minus 3y minus 5 equals to 0. If you change the signs, we can cancel out this one. And next you are getting minus 5. This is minus 3 equals to 0. So if you do the simplification, you will get y value as minus 3. To get the x value, we are substituting the y value in second equation. Then you solve, you get x value as minus 2. So already we have put z equals to 0. Therefore, we got x, y, z values. Now for converting it into symmetrical form, we need LMN values, or we can tell even them as a comma, b comma, c values. Okay. So for that one, whatever the equations are there, those equations you have to write in place of x, y, z, you have to write a, b, c, and you have to with the help of the cross multiplication
Excuse me,
method.
ma'am.
Yes.
In every problem, we have to put z is equals to 0.
Yes. Wherever in the that is converting it to unsymmetrical form to symmetrical form, the procedure is one only.
Okay.
First, you have to put z equals to 0. After that, with the help of these two equations, you have to find the LMN values.
Okay.
Okay. So this method is useful for even 10 marks problems also. In some the problems, how they will ask means one line equation in unsymmetrical form will be there, and one line equation in symmetrical form will be there. So with the help of that, means one is unsymmetrical means like this it will be there, plain equations. Symmetrical means it will be in the form of x minus x1, that form. So directly you can't do one symmetrical and one unsymmetrical, no? So easy method will be converting the unsymmetrical into symmetrical form. Then with the help of the formulas, easily you can find the answer. Okay. For unsymmetrical and symmetrical also one method is there. So that will be somewhat lengthy process. You can use any methods. Here methods will be, two methods will be there, or three methods will be there for solving one problem only. You can adopt any one method for solving the problem. Okay. So now we got XYZ values. Now we need ABC or LMN values. Okay. So here let A comma B comma C, A comma B comma C be direction ratios of line 1. Since your sentence is there, since it lies on both the given plane, it is perpendicular to their normals where direction ratios are. So if you remember this one, write this sentence. Since it lies on both the given planes, it is perpendicular to this concept you have in first unit, where we have studied about the direction ratios and direction cosines. Okay, it is perpendicular to the normals where direction ratios are. So direction ratios are nothing but XYZ quotient here. It is 1, minus 2, 3. 1 comma minus 2 comma 3. And for this one, 2 minus 3, 4. Okay, these are the direction ratios of the line which are perpendicular to their parallel normals. Okay. So now hence we'll write the equations as hence in place of this XYZ you write it as ABC. That is A minus 2B plus 3C equals to 0. Next this is 2A minus 3B plus 4C equals to 0. Okay. These are the two perpendicular plane equations which are normal to the direction ratios. So by solving these two with the help of cross multiplication, solving these with cross multiplication method. Okay. So cross multiplication method means the quotient of B and here the quotient of B, and again after that C, after that A, and again you have to repeat B. Okay. So for this equation it is minus 2, 3, and this is 1, this is minus 2. For second equation it is minus 3, 4, 2, minus 3. If you do the cross multiplication, here you will get A, this is B, and this is C. So A divided by, if you say 4 to the minus 8, minus of minus is, this is plus, 3 3s are 9, equals to B by 3 to the 6, minus 4 is equals to C by minus 3 plus 2 to the 4. Okay. If you simplify this, this is 1, this is 2, and that is 1. 1, 2, 1. So A by 1, B by 2 is equals to C by 1. So therefore, A is equals to 1, B is equals to 2, C is equals to 1. Or else, if you have any confusion, you can write this is L, this is M, and this is N. Okay. So we know A, B, C, that is LMN values and also XYZ values. Now if you substitute in the that is a symmetrical formula is there, no, x minus x1, y minus y1. There if you substitute, you will get it as third point. Here we have no third point, x value is minus 2, minus 3 is 0. Third minus 2, minus 3, comma 0 is a point on line 1. Okay. From 2 and 3, this is 1, 2, 3 completed, no? So here this is the here in place of 1 point, direction ratios of the direction ratios of line 1 or 1 comma 2 comma 1. Okay. So this you take it as equation 4. Okay. And this whatever the point is there, this point you take it as 5. Okay. So this is the first line equation, whatever we have taken for solving the two equations, we have taken 2 and 3. Whatever these direction ratios are there, this you are taking as a fourth one. And yeah, whatever the point is there, that we are taking 5. So from 4 and 5, your wish, without taking those equations also, you can write the formula. Just whatever the values you got x, y, z, that you substitute that one. X minus of, this is x1, y1, z1. Okay, this is x1, y1, z1, and this is L comma M comma N. Okay, so x minus x1 minus of minus 2 by L. What is L value? That is A value 1. Y minus y1 minus 3 by M value is 2. Z minus z1 is 0 by N value 1. If you simplify this, okay, we will get it as x minus of minus means plus 2 is equals to y plus 3 by 2 equals to z by 1. Okay, is the equation of the line in symmetrical form. Okay, so you may remember those sentences or anything, but the procedure is this one. Okay, here direct what from the element values and from the point value, that is x1, y1, z1 values. After getting those two values, you can substitute in the formula x minus x1, y minus y1, z minus z1 by A, B, C, or else L comma M comma N values. Okay. So this is the procedure for finding the unsymmetrical form to symmetrical form. Okay. So in this only you have the formula for finding the angle also you have. This is also important. One will be in the plane equation and another will be in the that is in unsymmetrical form, and one will be in the symmetrical form. Where it is? Page number 106 you have. Angle between a line and a plane is the complement of the angle between the line and the normal of the plane. Okay. So we find the angle between the line x minus x1 by L equals to y minus y1 by M equals to z minus z1 by N, and the plane ax plus by plus cz plus d equals to 0. Okay. So the formula to find the angle between a line and also one of the plane, it is cos pi by 2 minus theta. So that is called as sin theta. We know 90 degrees minus theta means sin theta is equals to AL plus BM plus CN divided by root of A square plus B square plus C square into root of L square plus M square plus N square. Okay, this formula is also important. It is in page number 106. So on this also you will get one 5 marks question. You have in 107 page number. Check your progress. It is there, no? So you may have chance of this one or this angle problem also. Check your progress, third and fourth question. So find the angle between the line. It is in the symmetrical form, it is there, and one plane equation is given. So in the denominator, you have whatever the values are there, those are L comma M comma N values. And here in the plane equation, you have A, B, C values. So if you substitute in the formula, you will get the answer. Okay. So this is about the angle between a plane and also line. So you practice that one. Example problems are given in the textbook. From that you can do. So after that we have coplanarity is there, and also point of intersection is there. In this only 107 page number only, if you see point of intersection of the line with the plane. So one line equation will be given and one plane equation will be given. So with the help of that, we have to find the point of intersection of the line with the plane. So that procedure condition for a line to line. So that is find the question will be like this: find the coordinates of the point of intersection of the line with the plane. So if you'll take the line equation as something, it is equals to k or r, rt, anything, any variable you can take. So the coordinates of the point on the line will be, if you do the cross multiplication, you will get x, y, z values. If this point lie on the given plane, then you will get the r value, and the point of intersection you will get from this one. Okay. This is also one of the problem. -2. And this is check your progress problem is there. So to find the point of intersection when one line equation is given and when one plane is given. So you can see the condition in page number 107. You have 4.4 point of intersection of the line with the plane. So with the help of that, we are solving one problem. Point of intersection of a line with plane. Point of intersection of line with the plane. Okay, line will be x minus x1 by L is equals to y minus y1 by M is equals to z minus z1 by N. So it is equals to R we can take, and this is the first line equation. Okay, and plane will be ax plus by plus cz plus d equals to 0. So this is line and this is plane. So any procedure will be any point on line 1. If you do the cross multiplication of this one, you will get it as, that is LR, and here x1 is there, minus x1. If you take that side, you will get it as x1 plus LR plus y1 plus MR z1 plus NR. This is the point x, y, z. If you do the cross, x minus x1 by L is equals to R, y minus y1 by M is equals to R, z minus z1 by N equals to R. If you do the cross multiplication and if you take x, y, z values, we get this point as the from here. Okay. And if you substitute that point in this plane equation, then you will get the point of intersection. Okay. This is the, you can take this as third equation. So 3 lies on 2. So if this point lies in this one, then you will get the point of intersection. Okay. So we'll see with the help of one problem. Example you can take. Find the coordinates of point of intersection of line x minus 1 by 2 is equals to y minus 3 by minus 1 is equals to z minus 4 by 1 with the plane 2x minus y plus z plus 3 is equals to 0. Okay. Given line is this one, x minus 1 by 2 is equals to y minus 3 by minus 1 is equals to z minus 4 is equals to r you take. Okay. This you can take as equation 1. Now if you do the cross multiplication, we'll get it as any point on line 1 is, okay, that is 2r plus 1, next to minus r plus 3, next to r plus 4. Okay. After that, what we have, any point on line 1 is this one. 3 lies on 2. And here you can take given plane equation is what? this one minus y plus z plus 3 equals to 0. This is equation 2 and this is 3. So 3 lies on 2. That is in place of x, y, z, we have to write in x, y, z, you have to put this point. That is 2 into 2r plus 1 minus r plus 3 plus z plus r plus 4 plus 3 equals to 0. So 2 to the 4r plus 2 minus into minus plus r minus 3 plus r plus 7 equals to 0. 4r, 5r, 6r. 2 minus 1. Minus 1 means plus 6. R equals to minus 1 you will get. Okay. So substitute this R value in 3. So what you will get? Minus 2 plus 1. Minus of minus 1 plus 2. That is minus 1, 4, 3. Minus 1, 4, 3 is point of intersection. Is point of intersection of a line and a plane. Of this line and this plane, the point of intersection is minus 1, comma 4, comma 3. Okay. This is the procedure to find, okay, to find the point of intersection when one line is given and one plane is given. Okay. Next, we have the concept of coplanarity is there. These all are the 5 marks questions. Whatever the coplanarity condition is there, that is important. So that will be asked for the 10 marks question. Okay. So you have to remember the formula. With the help of that, we can find the solution for the problem. Okay. Coplanar lines, conditions for the coplanarity of lines. So in this problem, almost the line equation will be in the symmetrical form. In some cases, they may ask one way unsymmetrical form, another in symmetrical form. Then you can convert them and then you can find with the help of the formula. Okay. So if two line equations are there, that is in page number 110, you have coplanar lines, condition for the coplanarity of lines. We find the condition that two given lines are coplanar, that the condition two given lines should lie in a plane. So when we'll tell two lines are coplanar means when the two given lines lie in a plane. In a plane, if two given lines, if they lie, then we call them as a coplanar lines. So equations will be in the symmetrical form. When they are in the symmetrical form, in one 111 page number, you have the formula is there. So one condition is here, 4 comma 5 comma 6 equations we have. No, this is the condition for coplanarity. X2 minus x1, y2 minus y1, z2 minus z1, L1 m1 n1, L2 m2 n2 equals to, if you'll get that value, determinant of that, if you'll get the value as 0, then the given two lines are coplanar, or we call them, they intersect each other. Okay. So then in the question for 10 marks, they will ask to find the condition of coplanarity, whether it is satisfying, and also they will ask to find the equations of the plane also. What you will get the equations for the coplanarity, that also you have the formula here. Okay. Conditions for the coplanarity of lines. For the coplanarity So first is the given lines will be in the form of like this: x minus x1 by L1 is equals to y minus y1 by M1 is equals to z minus z1 by N1. Okay. So this is one line equation. Next one is x minus x2 by L2 is equals to y minus y2 by M2 is equals to z minus z2 by N2. So the two given lines will be in the symmetrical form like this. So for this, the condition of coplanarity or the condition of intersection is, this is the main important formula, okay? x2 minus x1, y2 minus y1, z2 minus z1 by L1, M1, N1, L2, M2, N2. If this determinant value is 0, this is called as a condition of coplanarity. Okay, this is the condition. To find the equation of the plane, so for line containing the two lines, so for finding the equations, you can write either x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equals to 0, or else x minus x2, y minus y2. Okay. Any two equations, to get the two equations, we can write the two types. Okay. One will be like this: x minus x1, y minus y1, z minus z1 by L1, M1, N1, L2, M2, N2 equals to 0. Okay. This is one equation of a plane. We'll get through this formula. And another one is x minus x2, y minus y2, z minus z2, same L1, M1, N1, L2, M2, N2 equals to 0. So from this, we'll get the plane equations. So question will be to show that the lines are coplanar and find the equations of the plane he will ask. So for condition of coplanarity, this is the formula. And for finding the plane equation, this is the formula. Okay. So this formula is important for coplanarity and also for finding the point of intersection. So after finding the determinant, if you are getting the value as 0, then the two lines are coplanar to each other. So we'll see one problem, that is prove that the lines intersect, find their point of intersection and equation of plane in which they lie.
This one, page number 112, sixth question.
This question, huh? Okay, we are seeing this problem, which means x minus 1 by 2. It is in MEQ, I think so. Wait. It is page number 125, seventh question.
Okay.
Yes, 38. Okay. Prove that the lines are coplanar, find their point of intersection and also equation of a plane containing them. Okay. This is the MEQ question. Prove that the lines x minus 1, sorry, 2 is equals to y plus 1 by minus 3 equals to z plus 10 by 3. H. And one more is x minus 4 by 1 is equals to y plus 3 by minus 4 is equals to z plus 1 by 7. Are coplanar, find their point of intersection and equation of plane containing them. Okay. So these are the two given line equations from this. Just now we have seen the formula. No? With the help of that, we have to find the first thing you have to show that they are coplanar. After that, with the help of these two any one equation if you take, it's enough to show that the equation of plane containing them. Okay. And for finding the point of intersection, first we have seen one problem. With the help of that, we have to find. Okay. Okay. Let given lines are let x minus 1, directly I am writing here, minus 3 equals to z plus 10 by 8 equals to r. Okay. Wait a bit. Okay. You take this as equation 1. Next one is what we have, x minus 4 by 1 is equals to y plus 3 by minus 4 equals to z plus 1 by, this is the second equation. So for condition of coplanarity, we have no condition of coplanarity. So this is x minus x1, this is x1, y1, z1, this is x2, y2, z2. So formula is x2 minus x1, y2 minus y1, z2 minus z1. So x2 is here, minus 4 is there. Or that is x minus x, formula is x minus x1, y minus y1. So already minus is there, therefore x1 value is 1. Here x2 value is 4, that is 4 minus 1. Next, this is minus 3 you will get, y2. Minus 3 minus 1. Next, this is minus 1 minus 10. Then 2 minus 3, 8. 2 minus 3, 8. 1 minus 4, 7 equals to. So you know, just you convert this one, then you find the determinant. 4 minus 1 is 3, minus 4, minus 11, 2 minus 3, 8, 1 minus 4, 7. Okay. If you find the determinant of this one, so that is 3 into minus 21, minus of minus plus 32, minus of minus, this is plus 4, 7 to the 14, minus 8, minus 11 into minus 8, minus of minus plus 3. That is minus 21 and 32. So how much you will get? 11, no? So plus 11 you will get. 11 3 is 33. Plus 14 minus 8 means 6 you will get. 6 plus 24. Minus 8 plus 3 means minus 5. Minus of, you are not getting it, is equals to 0.
Plus 55.
Plus, all you are getting plus only, no? 57.
Ma'am, minus 11 place లో plus 11 I తీసుకుంది.
Minus 8. Minus of minus plus. Already here we have 4 x2 minus x1. 4 minus 1. This is minus 3. This is minus 1. Minus 3 minus 1. This is minus 1. This is minus 10. So minus 11. 2 minus 3, 8. 1 minus 4, 7. So 4 minus 1, 3 minus 4 minus 1, correct only. Minus 21. Minus of minus 4, it's a 32. Correct only. This is minus of minus, this is plus. 7 2s are 14. Minus 8. Minus 11. Minus 8 plus 3. Correct only this one. 14 minus.
There is -4, we are taking +4.
When you take the determinant, this value you'll get as a minus, no?
Yes. And
Middle.
same -11 is equals same as it is -11.
It is minus 11 only. In while finding the determinant, this value, this and this and this values. These
Yeah.
will be a minus. Okay.
Yeah.
You know that cofactor means minus 1 to the power of I plus j, no? So this is in the second column and first row. So 1 plus 2 means cube you will get. So this value, this you'll get as 5, this you'll get as 7, and this you'll get as 9. So these all, whatever the odd powers are there, though you'll get as a negative values. So blindly you can remember that this value, this and this and this in the middle. These values you'll get the negative value. So minus and already the sign will be minus. So minus of minus means it will become plus 4.
Yes.
7,
Then
4.
-11 same as it is -11.
Yeah, as 11, because this is the positive value. No?
Yeah.
S into minus means minus only you will get. That is only minus 8 plus 3. So you have to get it as a coplanar, but you are not getting the condition of coplanarity. Problem correctly is there. 2 minus 3, 8. Minus 4 plus 3, 4 minus 1. The question it is given, prove that the lines are coplanar, means compulsory whatever the determinant is there, that's you should get as 4 of minus 11 minus 21. Is a 33, 6 4 the 24. This is minus 5, minus of minus is 55 you will get. Here we are getting 57. 2 minus 3, 8. 1 minus 4, 7. So directly if you do, this is you are not getting. From one more method is there. Is asking to find, show that the two lines are coplanar. Find the point of intersection and the equation of the plane containing them. But the formula is this one only. For this, you are not getting the point of intersection. It is the coplanar.
Excuse me, ma'am.
Yes.
This is page number 124. 6 to 7. Can we do like that?
Yeah, like this also we can do. By that, it is showing that the given two lines are coplanar. But actually, formula is like this, no, to find the coplanarity. The condition is this one, no. It should also get the same answer, but you are not getting for this one. 1 minus 4, 7. This is the one method. Another method is whatever you have shown, no, that is another method. Okay, see by second method. Just you take here, it is equals to R. it is equals to R. Then you do the cross multiplication. So you'll get it as 2R plus 1 minus 3R minus 1, 8R minus 10. Okay. These are the XYZ values. Now this whatever the point is there, this point lies in the second line equation. Okay. If it lie on line, that is x minus 4 by 1 is equals to y plus 3 by minus 4 equals to z plus 1 by 7. Then that means in place of x, y, z, you have to substitute this point. So that is 2r plus 1 minus 4 by 1 is equals to minus 3r minus 1 plus 3 by minus 4 is equals to 8r minus 10 plus 1 by 7. Okay. We'll do the simplification. 2r minus 3 by 1 is equals to minus 3r plus 2 by minus 4 is equals to 8r minus 9 by 7. Okay. Now you do the cross multiplication of either these two or one, that is 1 and 2, 2 and 3 or 1 and 3. With the help of that, we need to find the R value. So that means if you do the cross multiplication of these two, what you'll get minus 8R minus into minus plus 12 is equals to minus 3R plus 2. That is minus 8R plus 3R plus 12 minus 2 equals to 0. Implies minus 5R plus 10 equals to 0. Implies minus 5R is equals to minus 10. R equals to 2. Okay. R equals to 2, you substitute in this one, in this point. So you get it as so what you'll get 2 2s are 4, 4 plus 1 means 5, minus 6 minus 1 minus 7, 8 2s are 16, 16 minus 10 means 6. So 5 minus 7, 6. This is called as a point of intersection. Okay, in the question what is asked, are coplanar, find their point of intersection. We have got the point of intersection. So in the before this problem, we have seen one problem in that one line equation was given and one plane equation was given, and he has asked to find the point of intersection here, but two line equations are there. So with the help of this, we are finding this point. This is called as a point of intersection. Is a so how we can say that this is the point of intersection means here R equals to 2 value, no? You substitute in this one. If all the values you are getting, these three values are same, then this point is called as a point of intersection of these two lines. And they are coplanar. This is one more condition for finding the coplanar. So we got this point now. Substitute R equals to R is from here only you write this one. So we got R equals to 2. R equals to 2 in this one, you take it as third equation. So if we substitute here, 2 2s are 4, 4 minus 3 by 1 is equals to 3 2s are minus 6 plus 2 by minus 4 is equals to 8 2s are 16 minus 9 by 7. Okay. So 4 minus 3 is 1 by 1. This is minus 4 by minus 4. 16 minus 9 means you will get 7 by 7. Okay. So minus minus gets cancel. Here you will get 1 is equals to 1 is equals to 1. Okay. So this whatever R equals to 2 value, it is satisfying the when you substitute here, you're getting the values as same. That means the two lines are coplanar to each other. Okay. Therefore, here you can write the given lines are coplanar to each other. Are coplanar, directly you can write. Don't write it. Are coplanar, and he's asking to find the point of intersection. Now you write, substitute r equals to 2 in second equation. So what we got? We get 5 minus 7 comma 6. So this whatever point is there, this point is the point of intersection for the line. Given lines we are not written. Given lines are coplanar, or you can write the lines, the given lines intersect. Okay. When you substitute r equals to 2 in second equation, we get 5 comma minus 7 comma 6 is the point of intersection. Okay. So this is one procedure. In the question, if he is asking to show that the two given lines are intersecting and also find the point of intersection, this is the procedure. If only coplanarity is there, means we can see one more problem. For this problem we didn't got, but once again you check that one with the help of coplanarity conditions are there, no? And in this problem only is asked to find the equation of plane also. Okay, this is only half part. One more part is there for finding the equation of the plane. So one method is with the help of the formula determinant of x2 minus x1, y2 minus y1, z2 minus z1, l1 m1 n1, l2 m2. When the determinant is equal, whatever the value, if you're finding with the help of the determinant, if you will get that value as 0, then the given two lines are coplanar to each other. And if he's asking to find the point of intersection, then you take any one of the line equal to r and you will get one point here. Substitute that point in the second equation, and after getting the second equation, substitution of this point, you do the cross multiplication and you find the r value. When you substitute that r value in the equation, if you get the 3, whatever the resultant are equal, if you are getting, then the given two lines are coplanar or they intersect each other. Okay. So for finding r, that is a point of intersection, you have to substitute r equals to 2 value in the third equation. Then you will get one point, which is the point of intersection. Okay. So this is one procedure, and another one is direct formula with the help of formula. For this one more is find the equation of the plane. For finding the equation of the plane, formula is there, no? Direct with the help of that formula you can find. The equation of plane containing them is the equation of plane containing them is, so what is the, directly we'll write. First equation is x minus 1, y plus 1, z plus 10. Then 2 minus 3, 8. Then 1 minus 4, 7 equals to 0. So anyone you can take x minus x1 or x minus x2. So for this also now we need to find the determinant. So first, I hope you all know how to find the determinant. So first column and first row, you have to eliminate this one, and whatever the minor 2 by 2 minor you will get, no, that you have to do the cross multiplication. Okay. So that is first x minus x1, this, and you have to eliminate this column and this row and multiply this one, that is 7 minus 21 minus of minus plus 32. Now this will be negative, that is minus of y plus 1 Now this column and this row, if you eliminate, 7 2s are 14 minus 8. Okay, plus z plus 10 into only first row elements. Okay, for finding the determinant. Like this only, if you know the concept of finding the determinant, you have in intermediate, I think so. And in your this degree level matrices where you have in a core you have no for finding the determinant and finding the rank of the matrix you have.
Yes,
Okay?
ma'am.
From there you can see the concept of finding the determinant. So z plus 10, if you eliminate this column and this row, minus 8, this is minus of minus plus 3. Okay. Minus 8 minus of minus plus 3. So x minus 1, x minus how much we got? 11. And this is minus y plus 1, 14 minus means it is 6 here, plus z plus 10, this is minus 5. So this is same, you will get x. 1 if you multiply means x minus 1 only. With the 6 you multiply, this is minus 6y minus 6. And this is minus 5z minus 5 times of 50 equals to 0. So this is x minus 6y minus 5z. Minus 1 minus 6 minus 7. So minus 57. Okay. Same you got. So this is 11 now. This is 11x and this is minus 11. So 11x minus 6y minus 5z. This is minus 11. So minus 11 minus 6 means minus 17. So you will get it as minus 67. This is equals to 0. So if you want one more equation of the plane, then you can take second line equation and you can find one more equation. So it's enough if you'll find one plane equation. Okay. So either you can find with the help of first line or with the help of the second line. Okay. So this is the equation of the plane containing them. So these such type of problems you will get for the 10 marks questions. So some example problems and check your progress are there. For direct coplanarity also, you can see those example problems. So in this only one more concept for finding the coplanarity and also plane. I have told now one line equation will be in the symmetrical form. Another line equation will be in the unsymmetrical form. Okay. One method is whichever line equation in unsymmetrical form is there, that one you can do with the help of the converting into symmetrical form and then directly applying the formula that is x2 minus x1, y2 minus y1, that formula, and you can do the problem. Or else directly with the help of the unsymmetrical and symmetrical also you can solve the problem. Okay, that we'll see in the next class. And after that, so on this you have questions are there in the MBQ questions. After that, we'll go to the second unit, unit 5. Unit 4 and 5 are important units in block 2. Okay. So up till next week, you try to solve those. See, tomorrow only we have class, no? So tomorrow we'll see the one more problem on symmetrical and unsymmetrical form of the line equations to show them as a coplanarity, or else for intersection also same condition. It should be equal to 0. Or else with the help of this problem we have done, no, it is equals to R we have to take, and then we have to find the, if he's asking in the problem to find the point of intersection, same procedure you have to follow. Okay.